Okay, so now let me do again the same discussion. Let's go through the same discussion about changing in potential, changing electric potential, but now for a negative charge. Okay, so let's again repeat the story about our two plates. Here I have a positively charged plate. Here, as we said, we have high potential, electric potential. On the other side, I have the negatively charged where we have low potential. Okay, very well. And now I'm going to start playing with a negative charge. Remember what we said before in the previous slide. If we are dealing with a positive charge, the positive charge goes from the high potential to the low potential. Now I'm going to play with a negative charge. So here I have my negative charge. My negative charge moves from low V to high V. Okay? So if I want to write these equations that we talked about, which is given by the final potential minus the initial potential, in the case of a negative charge, okay, in the case of a negative charge moves from low to high. In the case of a negative charge, this is going to be positive. No? So this change in potential for a negative charge, this change is going to be positive. Okay? And well, the rest continues. The rest is still the same. What is this change in potential? Using the definition of potential is going to be the final potential energy minus the initial potential energy divided by Q. Final potential energy minus initial, this number here is negative because the charge is losing potential energy. Now this charge is negative, okay? So the whole combination of negative potential, change in potential energy and negative charge will give us plus. So you see that things are consistent. Okay, we wrote before that the change in potential energy is equal to minus work divided by Q. Well, the work is positive. The work is positive. The charge is negative. We have here this negative sign. And again, we are going to get for this whole thing plus. What else do we have? We said that the work is given by, it can be written in terms of the electric field. Okay, so let's continue writing this here. We have minus. Now, what is the equation that we wrote for the work for a negative particle? Now, the work is positive, but since the particle is negative, the way that we wrote was minus Q E T. Okay, because this Q here is negative, right? Electric field is just the magnitude, the D is just the magnitude of the displacement, so negative with this negative sign guarantees that the work is positive. Okay, we are studying here change in electric field, right? So, we are studying here change in potential, electric potential, so I have to divide all this by Q. Okay, so we have minus and minus, which will become plus, so I'm going to write here final potential minus initial potential, minus and minus becomes plus, Q and Q cancel, and we have here E D. Again, this is just magnitude of the electric field, D is just a magnitude, and I'm getting here positive value. Makes sense. This change in potential for a negative charge is positive. So you see again all of those equations that we can extract as we did for the positive charge. What are the equations that we can extract? Well, let's see, for example, the equation for the work. The work is equal to minus Q final potential minus initial potential. This is one equation, the equation for the work. The work done by the electric force to move this particle along its natural motion. Okay, what is going to come out from here? This potential difference for the negative uh, particle is positive. This is a negative particle. No? So this work is going to be positive. What else did we get? We see that the electric field is given by final minus initial potential divided by D. And you see that there is no sign here, huh? As we had for the positive charge. So there is no sign here. Why? Because the change in potential for the negative particle is positive. Okay? And this equation here, this is an equation that gives us the magnitude of the electric field. Okay? Very well. So this is the story of the negative particle.